Good morning everyone. Myself Dr. Trina, Assistant Professor, Chemistry Department, JIS College of Engineering. So today I will tell about BOD. So the subject name you know that I teach you. Environmental Science, that is MC 301 for odd semester, MC 401 for even semester. So today's topic is BOD, that is the biological oxygen demand. Now can you tell that what is biological oxygen demand? Demand means the requirement of the oxygen. So for which purpose it is required? Is it for respiration? No, it is not for respiration. It is required to decompose the organic waste materials. It may be the dead plants, it may be dead animals. So organic matter, when it is decomposed, so we require oxygen. Organic matter plus oxygen in presence of microorganism, we get CO2, and salts of nitrate, sulfate, phosphates and new cells, the new cells of bacteria. So this is the first order reaction. So if it is in presence of oxygen, that is called aerobic reaction. If it is in absence of oxygen, that is called anaerobic reaction. So if it is in absence of oxygen, we get it is the anaerobic reaction. And instead of this, we get H2S, ammonia, etc. That is why we get very bad smell. Where there is anaerobic reaction, there is the less amount of oxygen. So now I told you what is the BOD? That is the amount of oxygen required to decompose organic materials in presence of microorganism. So you have learnt the definition of BOD and the reaction of BOD. Now you will learn that how we can determine BOD by the 5-day BOD test and the related problems. So in 5-day BOD test, what we do, first we take a 300 ml bottle. So I am showing properly. This one is 300 ml bottle. have taken 300 ml BOD bottle, and here is the wastewater. It may be 20 ml, it may be 25 ml, anything else, and rest is filled up by dilution water. Now, initially we calculate the dissolved oxygen present in this bottle. So, dissolved oxygen, you know that the oxygen remains in the air, as well oxygen remains dissolved in the water. That is the dissolved oxygen. We write DO, that is the dissolved oxygen. So, initially we take DOI, that is the initial dissolved oxygen. Then after 5 days again we determine the amount of dissolved oxygen present in this bottle. That is, say after 5 days, that is DOF. So the final dissolved oxygen represented as DOF. So initial dissolved oxygen, that is DOI, final dissolved oxygen DOF. Now can you tell that this amount, which one is higher? DOI is greater or DOF is greater? Anyone? Yes, of course DOI will be greater. Why? Because where the oxygen, that means the dissolved oxygen is going, dissolved oxygen is consumed to decompose the organic matter which is present in the wastewater. This is the wastewater. So, DOF is less than DOI, or I can write DOI greater than DOF. So, how much oxygen is consumed? So, we get the oxygen consumed, that is DOI minus DOF. So, now I am going to write DOI minus DOF. That is the amount of oxygen consumed. So BOD T, for T is the time. It may be 10 days, it may be 15 days, but generally we do for the 5 days. So we tell 5-day BOD test. And 5-day BOD test done generally at 21 degrees centigrade temperature. So here BOD T is equal to DOI minus DOF divided by P. So you have learned DOI means initial dissolved oxygen, DOF means final dissolved oxygen, and P is the dilution factor. So DOI P is the dilution factor. Dilution factor means the amount of wastewater divided by total volume. So that is equal to volume of wastewater divided by total volume. So first case you have seen the volume of wastewater may be like 20 ml whatever, and total volume will be always 300 ml because we are taking the BOD bottle that is of 300 ml. The volume is 300 ml. So we are taking their wastewater plus dilution water. So total volume will remain same, that is 300 ml. Now get a problem, you will be more clear. here it is given the wastewater 25 ml and dilution water, rest is dilution water. That means 275 ml dilution water, because the total volume is 300 ml BOD bottle. Now the initial DO. It is given the initial DO is 9 milligram per liter, final DO that is 3 milligram per liter. So the BOD value will be equal to BOD, say 5 for 5 days, generally we do it, 9 minus, because you know the formula, that is DOI minus DOF by P, that is equal to 9 minus 3. What is the value of P? That is 25 divided by 300. Nine minus 3, 25 divided by 300. What will be the unit? It is milligram per liter. Milligram per liter. So just you calculate and you will get the result. Okay, so you have learnt to do the very simple BOD formula, that is the simple BOD formula. That BOD is equal to, remember this equation, that is very important equation, that BOD is equal to DOI minus DOF divided by P. Now I am going to tell you about modified BOD formula. That is a simple BOD formula. Now the modified BOD formula. So first we are taking a bottle which contain wastewater plus dilution water. So what is the problem we have done in the simple BOD formula? We have not considered about the BOD of this dilution water, because this dilution water itself has BOD. So we have calculated BOD of this total bottle, but to get the BOD value of this wastewater, we have to subtract the BOD value of the dilution water. So one case we have taken, that is the DOI. This case we have taken DOI, initial dissolved oxygen, and we are taking DOF, that is the final dissolved oxygen. So same way we have to take another BOD bottle, similar BOD bottle. Although it is thinner, but actually the volume is same. Both are 300 ml BOD bottle. And this contains only dilution water. This contains only dilution water. Here it contains waste plus dilution water, that is the waste water, and here it is the dilution water. Now for this case we cannot represent the same way as DO. That is why dissolved oxygen initially represented as BI and final dissolved oxygen represented as BF. So now what will be the formula? If we subtract the BOD value of dilution water from the total BOD value, we will get the BOD of wastewater. So the modified BOD formula that is the modified BOD formula. DOI minus DOF minus BI minus BF into 1 minus P divided by P. And P is the dilution factor in the same way. So now you write a problem, say for DOI is equal to 9 milligram per liter. Say DOF is equal to 3 milligram per liter. BI is equal to 8 milligram per liter. BF is equal to 2 milligram per liter. And for the bottle, say it is given the volume of wastewater, say 21 ml, and the rest is dilution water. So the P will be equal to 21 divided by 300. Now just put in this equation and you will get the BOD. So I am writing the value here. So DOI I have given 9, DOF 3, BI is 8, BF is 2, 1 minus dilution factor, that is the 21 divided by 300. And here only P, that is the 21 divided by 300. Just calculate and you will get the result, and unit will be milligram per liter. So in this way you can calculate the BOD value for wastewater sample. So if I summarize the today's lecture, what you have learned today? Number 1, BOD, the definition. BOD, the reaction. Number 3, 5-day BOD test. Number 4, the related problems on simple BOD formula. Simple and modified BOD formula and related problems. So now you go through my digital content test.com, and I have already given you the assignment also. So upload your assignment. So thank you for today.